So we shall recap this idea of simultaneous equations. The most common method is known as the elimination method. So we want to eliminate a variable. Then once we've eliminated one of the variables, I'll go and solve for the other variable. Once we've solved for one of the variables, we can then substitute back in and work out the eliminated one. So that's just a basic one. There's two equations. So to eliminate, we want to make the coefficient of x or the coefficient of y the same. Doesn't matter about the sign, just basically the number itself. I wonder which way I went. Did I make the x's or the y's? What did I do? I've multiplied the first one by 2 and the second one by 3. So the y's are the same. Okay, so I can do a subtraction. And I'm actually subtracting upwards here, so I end up with a positive number. Doesn't matter. But 11x is negative 33. So x is negative 3. I can now go substitute back in. Y equals 9. Sometimes people don't bother with that substitution step, and they just write, therefore y equals 9, because, well, a lot of the time it's a very easy substitution. And that's fine. Just be careful you don't make a silly mistake in that substitution. But when we write our final answer down, we should conclude the problem. It's not up to whoever's looking at your solution to tie everything together. I mean, imagine my last line's not there. I've got x equals negative 3 over here on the left-hand side. Over here on the right, I've got y equals 9. Why should people have to go searching for the answer? So I finish it off by grouping them together, just to underline to sort of say, here it is. This is the solution. X is negative 3, y is 9. Oh, and by the way, don't write it as a set of coordinates. They might be x and they might be y, but unless this is a coordinate geometry problem, they're just pronumerals. Yes, sure enough, if we were using this to find the point of intersection of two lines, then I'd write the answer as coordinates, because that makes sense for that problem. But if this is simply saying, hey, find these values, it's just a coincidence that I used x and y, when I could have used a and b. This one. The elimination method doesn't work real good. And that's probably poor grammar right there, isn't it? Real good. Yeah. Because I can't multiply and get the coefficients the same, because technically we've actually got 4 different pronumerals there. Because x squared is a different pronumeral to x, and so on. So this is the one we use a substitution method. So I'll rewrite the first one to make, and I'm going to make y the subject. Now it's logical to do the first one, because if I did the second one, I'm going to end up with like y equals plus or minus the square. It's messy. We want to make life as easy for ourselves as we can. And I guess the reason I chose y is because it's already 1y, whereas if I did the x, I'd have to do a divide by 2. Not that that's a big deal, but, you know, let's try and make it as easy as we can. So y is going to be 14 minus 2x. Substitute that into the second one, and I will end up with a quadratic equation. Wouldn't it be nice if 3 went into everything? No, it doesn't, because 5 and 2 are 7, aren't they? Damn. Oh, and for that matter, 5 and 6 are 11. Do you realise what I'm doing, by the way, there? Remember, something to be divisible by 3, the sum of the digits have to be divisible by 3. So, okay, ends up being factorised this way. 3x minus 41, x minus 5. So we actually have 2 possible solutions for the x, which therefore means there's going to be a corresponding 2 solutions for y, which I can get by substituting into 14 minus 2x. So there's my 2 possibilities. And again, tying it together, there's my solution. So either x is 5, y is 4, or the other possibility, x is 41 on 3, y is minus 40 on 3. Let's have some fun. There's no reason why we have to restrict ourselves to 2 pronumerals and 2 equations. Anytime you have the same number of equations or more than the number of pronumerals, as long as one's not simply a multiple of the other, you should be able to find the values of those pronumerals. If this was a coordinate geometry problem, we're actually talking about a 3-dimensional space. because we now have an x-axis, a y-axis, and a z-axis. So it's like you've got to imagine a three-dimensional space. So we're now talking about 3 lines, but in a three-dimensional space. So it will also have a point of intersection somewhere, these 3 lines, in this three-dimensional space. Unfortunately, we don't do three-dimensional geometry anymore. Such a shame. It's really good fun. Still the same idea. I want to eliminate variables. So I'm just going to choose a pair of them and eliminate a variable. And then I'll choose a different pair and eliminate the same variable. So I've chosen to multiply the first one by 2 and match it with the second equation. And so the coefficient of x I've made the same. Do a subtraction, I've ended up with 7y minus 6z. So now I'm going to pick another pair and eliminate x from that. So this time I'm going to multiply the first one by 4 and match it with the third equation. What I now have is 2 equations, 2 pronumerals, the standard sort of question we're used to doing. So now we go and do that. So I've multiplied the second one over there by 6. So now I'm going to eliminate the z's, and I end up with y equals -2. And so now all I've got to do is work my way back through the problem, and I can work out the other variables. I've got 2 equations here I can use to find z. So sub that in. So I now know z is 4. And now I can go back to one of the 3 original equations and work out what x is. So substituting in for y and z, there's x. So x is 3, y is -2, z is 4, or if we were in our three-dimensional space, it would be the point 3, -2, 4. Okay, whoa, triple asterisks. That must be fun. All right.